Hello everyone, I hope you are all doing well. My name is Mr. Abdurrahman. Today I'll be talking about reflection, refraction, absorption, and transmission. Let's get started with the reflection. What is reflection? Reflection is when light bounces off an object. If the light strikes a smooth and shiny surface like water, glasses, and or polished metal, the light will be reflected at the same angle as it hits the surface. Here, the incident angle is equal to the reflected angle, and this is called specular reflection. If the light hits a rough surface or not smooth surface, the light will be reflected in different angles, and this is called diffused reflection. In diffused reflection, the surface is not smooth, it's rough. Light is reflected in different angles. Specular reflection, the surface is smooth, the light is reflected at the same angle as it hits the surface. Let's move to transmission. Transmission easily is the passing of light. Light is not absorbed, either reflected, just pass through the medium. The third part of my presentation is refraction. Refraction is when light changes its direction as it moves from a medium to another medium. Why? Because the refractive index of the two materials are different, so the speed of light will be different. The refracted ray will be bent either closer to the normal or away from the normal. Index of refraction equals to the speed of light in vacuum, which is 3 times 10 to the power 8 over the speed of light in material. Here, when the light is traveling or passing from denser medium to this dense medium, from the water to the air, the refracted ray will be bended away from the normal. So theta R here is greater than theta I. In the second case, when the light is traveling from less dense medium to the denser medium, from the air to the water, so the refracted angle will be smaller than the incident angle because the refracted ray will be bended closer or will get closer to the normal. Let's move to the Snell's law. Snell's law is the law shows the relationship between the incident angle and the refracted angle. Here, N1 and N2 are the refractive index for the first medium and the second medium. Theta 1 is the incident angle, theta 2 is the refracted angle. Let's get an example here. When light passes from air into water at an angle of 60 from the normal, what is the angle of refraction? As we all know, the refractive index of the air is 1. Refractive index of the water is 1.33. The incident angle, which was given in the question, is 60. By using Snell's law, we must find theta 2 here, dividing both sides by n2 and putting the given information. We get this number. Taking the sine inverse of 0.6511, we get theta 2 equals to 40.62 degree. You can check that by using your calculator. Total internal reflection. When light is traveling from denser medium to less dense medium and the angle of incident is greater than the critical angle, the light will be reflected or will return to the denser medium. Let's check which one of these is a total internal reflection. In 3 cases, the light is traveling from denser medium to less dense medium, from the water to the air. But in the first case, the theta 1 is less than the critical angle, so the light is refracted to the second medium, and theta 2 is greater than theta 1 here. At a certain angle, which is the critical angle, the light will follow a path along the surface of the denser medium. It will not go to the second medium. Total internal reflection here, because light is traveling from denser medium to less dense medium, from the water to the air. Theta 1 is greater than the critical angle, so the light is reflected inside the denser medium. There are 2 conditions for the total internal reflection, as I mentioned before. Light must travel from denser medium to less dense medium, and the angle of incidence is greater than the critical angle. Here, angle of incidence is less than the critical angle, light is refracted, and the refracted angle is greater than the incident angle. At a certain point, which is the critical angle, the light will follow a path along the surface of the denser medium. Third case, angle is greater than the critical angle, so this is total internal reflection. As you can see, the light returns to into the first medium, which is water. Air, water is denser than air, the angle is greater than the critical angle, the light will return denser medium, total internal reflection. Another example of the total internal reflection is fiber optics. The light inside the fibers is reflected many times until it gets to the desired point. This light can carry a huge amount of information. The last part of my presentation is absorption. Absorption is when light is taken in, is not reflected or transmitted. When light hits the surface, the light will be converted into different forms of energy. When light is absorbed into a surface, it's transformed from light energy into a heat energy. And there is a question, why wearing a white t-shirt in sunny days is cooler than wearing black or dark t-shirts? The reason is that the dark or the black t-shirt absorbs more light than the light or the white t-shirt. So we heat, it's hot if we are wearing black t-shirts. Another example of reflection and absorption is when the light from the sun strikes the grass. Only the red color is reflected to our eyes, and the other colors, red, orange, yellow, blue, are absorbed by the grass. So we can see only the red color. Thanks for listening and wish you all the best in your exams. See you soon.